Hey everyone, today we're going to be talking about moles and conversions with moles. So to start off, you might be wondering, well, what is a mole? The mole measures the amount of substance, so therefore it is a unit. There are two ways the mole can be used. The first way is as a number, kind of like a dozen. So just like a dozen represents 12, the mole represents a number, specifically Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd. And this number can be used to represent a ton of different things, like oranges, molecules, or even something like paper clips. It can be used to represent literally anything. Now, 1 mole is 602 sextillion. That's really, really, really big. But we also have to remember that molecules are extremely small. So, 1 mole of molecules of H2O is only equal to approximately 18 milliliters. That's just because molecules are so small. So you might be wondering, why do we even use moles in the first place? Well, we use moles so we have enough molecules to see and deal with. Like, we can't really see one molecule or manipulate it that much, but we can see and deal with a mole of molecules, right? If we have approximately 18 milliliters of water, we can see and deal with that, and that's the reason we use moles. The second way the mole is used is as a conversion factor. 1 mole of any element weighs the numerical equivalent of its atomic mass in grams. Sorry, for some reason there's 2 dots there. So 1 mole of hydrogen is equal to 1.01 grams. And if you haven't already, I would recommend that you go check out our video on the periodic table, because that's going to help you understand the rest of this video. So give that a watch and then come back and look at this. So 1 mole of hydrogen is going to be equal to 1.01 grams because the atomic mass is 1.01, and we said 1 mole of any element weighs the numerical equivalent of its atomic mass in grams. So this is true for any element, right? So if we have 6.02 times 10 to the 23rd carbon atoms, we have a mole of carbon atoms, therefore it weighs the numerical equivalent of its atomic mass, so 12.01 grams. We can also restate this in different ways. So we can say the mass of one atom, in AMU times Avogadro's number is equal to the mass of 1 mole of that element in grams. So if you're using carbon as an example, if we have the mass of one atom in AMU of carbon, so we're going to say 12.01 AMU, times 1 mole of atoms, or 6.02 times 10 to the 23rd atoms, that's going to be 12.01 grams. So we're saying 1 mole of carbon is essentially equal to the numerical equivalent of its to the atomic mass in grams, so that's going to be 12.01 grams. Hopefully that makes sense. And also, this gives us a conversion factor between AMU and grams. So we're just going to restate this first thing over here in one more way, and we're going to use molar mass to do that. So molar mass is the number of grams per mole of a substance. So what is the molar mass numerically equivalent to? Pause the video and think about that. Remember that it's essentially restating what we said here and here in one more way. So the molar mass is numerically equivalent to its atomic mass in AMU. And that's because the molar mass is the number of grams per mole of a substance. So if we have 1 mole of that substance, the number of grams is going to be numerically equivalent to its atomic mass. So hopefully that makes sense. What we basically did here is restate this first thing in 3 different ways. Okay, so now we can use this conversion factor we found between AMU and grams over here with conversions with moles. So we can convert from atoms to moles and moles to mass. Let's start with atoms to moles. 1 mole is equal to 6.02 times 10 to the 23rd atoms, and we can use this to convert between atoms and moles. So at this point, I would recommend finding a periodic table online so you can do these problems by yourself and then watch the video and check your answers to see if you understood it. But if not, if you can't find a periodic table, no worries, because I'll be giving you the conversion factors here. However, it might be good to find it just so you can practice looking at the periodic table and solving these problems yourself. Okay, so if you have 3.78 moles of zinc, how many atoms of zinc do you have is the question. So we want to end up with atoms over here. That means we have to put moles in the bottom for this conversion factor in order to cancel out the moles. So we're going to do 1 mole of zinc in the bottom. And that's equal to 6.02 times 10 to the 23rd atoms of zinc. So get out your calculator and you can type this in. So 3.78 times 6.02 times 10 to the 23rd. And that's equal to 2.28 times 10 to the 24th atoms of zinc. So that's how we solve this first problem. I'm just going to highlight that because that's your answer. Now, our second conversion is from moles to mass. So the conversion factor comes from the periodic table for this one, and that's another reason why I asked you to find a periodic table. So 1 mole of any element is equal to the mass of that element in grams. So basically what we stated up here, that 1 mole of any element weighs the numerical equivalent of its atomic mass in grams. So 1 mole of carbon, for example, is going to weigh 12.01 grams. So now our practice problem, if we have 1.345 moles of chromium, how many grams of chromium is that? So if you don't have a periodic table right now, that's fine. I can tell you that 1 mole of chromium is equal to 52.00 grams of chromium. And you can find this on the periodic table. So over here we want to end up with grams, so we need to cancel out the moles. So put 1 mole of chromium down here. And then put 52.00 grams in the top. So 1.345 times 52.00 is equal to 69.94 grams of chromium. So now we've done 2 conversions, from atoms to moles and from moles to mass. So if you had the number of atoms, for example, you could end up with the number of grams through using these 2 conversion steps. You can go from atoms to moles and then moles to mass. And you can also do it vice versa. So if you have the number of grams, you can go from mass to moles and moles to atoms. So let's try to practice this with a big practice problem. So if we have 26.3 grams of carbon, how many atoms of carbon is that? And I'm going to give you the conversion factor from the periodic table. We know that 1 mole of carbon is equal to 12.01 grams. And this is if you don't have a periodic table with you. Okay, so please pause the video now and try to solve this problem by yourself. Then unpause it and we can solve it together. And you can check your answer. Okay, so 26.3 grams is what we have of carbon. And we want to end up knowing the number of atoms of carbon. So let's cancel out the grams and try to move to moles, because we can go from grams to moles and then from moles to number of atoms. So we have 12.01 grams, and again, this conversion factors from the periodic table. And then that's going to be 1 mole of carbon. And now I want to go from moles to atoms, so we know 1 mole of carbon is going to be equal to 6.02 times 10 to the 23rd atoms. Okay, so let's punch that in our calculators, right? 26.3 divided by 12.01 times 6.02 times 10 to the 23rd. And that's going to be equal to 1.32 times 10 to the 24th atoms of carbon. So hopefully all of that made sense. If you got this practice problem, that means you really understood this video and especially conversions with moles. So good job. I hope all of this made sense. If you have any more questions, I would recommend putting them below and I can come take a look at them and help you out. So I hope you enjoyed this video, and if you had any questions about the periodic table stuff in general, I would recommend looking at our video for that. So thank you so much for watching, and I hope you have a wonderful day.